A very warm welcome to all of you on behalf of MIDAS IT. I, Akash Sharma, welcome you to this webinar on pile-raft foundation analysis with superstructure and substructure, in which basically I mainly will be focusing on MIDAS GTS NX, and I will give a brief introduction about the capabilities of MIDAS Soilworks. So about the geotechnical webinar series which we have been conducting, the first was on May 13th, in which we basically discussed the slope stability analysis using the SRM and LEM method. Today's topic is pile-raft foundation analysis with superstructure and substructure consideration. And the next webinar will be on June 10th, the topic being the soil structure interaction for the short excavation using 3D finite element method. And the fourth one, that is on June 24th, the topic is the tunnel analysis and design using 2D and 3D finite element method. So talking about today's workflow, first of all, a brief introduction about pile-raft foundation. What is the need of pile-raft foundation? The favorable and unfavorable conditions for this particular type of foundation, and what is the design approach which is basically considered. Then I will be discussing the need of numerical analysis and how the design approach is involved with the preliminary and complete analysis in numerical methods. Finally, I will be dealing with a case study in which I will be modeling the superstructure and substructure in GTS NX, and I will be talking about its advantages. Finally, in the structure soil model, I would be talking about the rigid and flexible foundation response and how to determine the soil spring stiffness using GTS NX. To end with, I'll just give a brief introduction to PY nonlinear analysis, which is available in our 2D solution called MIDAS Soilworks. So pile-raft foundation. Foundation which makes use of raft and piles to reduce the differential settlements leading to considerable economy are referred to as pile-enhanced raft or pile-raft foundations. Now the need of pile-raft foundation comes into places where you need to reduce the maximum settlement, where you need to control the differential settlement, where one need to go for the economical design, or where lateral loads play a very important factor. Now what are the favorable conditions for pile-raft? According to Paulus, wherever the soil profiles consist of relatively stiff clays or relatively dense sand, it becomes very important, or it is a very favorable condition for pile raft. Why so? Because the raft has a very high bearing capacity in that case and provide a proper stiffness to the foundation. So the pile just act as a support which enhance the overall function of the pile raft foundation. The unfavorable condition for the pile-raft foundation are, first two, if you can see that soil profiles containing the soft clays near the surface or the loose sands near the surface, their pile-raft foundations are not recommended. Similarly, wherever there is a chance of consolidation, like where there is soft compressible layers at shallow depths, or where there is consolidation settlement due to external causes, there the thing happen is that the raft no longer remains in contact with the soil, and all the force is then taken by the piles, leading to excessive settlement in the long-term cases. And finally, we have the soil profiles which are likely to undergo swelling movements due to external causes, and it causes tension in the piles. So these are basically the favorable and unfavorable conditions for pile raft. Now the design approach for pile raft. It is a two-stage design process. First we basically call as approximate preliminary stage, and the second is the complete analysis procedure. Now in the approximate preliminary stage, it is just to assess the feasibility of pile-raft foundation for the project, that is one should consider it or not, and the estimation of the required number of piles to satisfy the design requirement. So it is just a first-hand calculation. Now the second is the complete analysis procedure, where one need to determine the spacing of the piles, the pile diameter, the pile location, or one can say the arrangement of the piles which is going for the project. Now what is the need for the numerical analysis? As you can see, there is a raft and there is a pile. So whenever you are considering a raft pile combination, there are different types of interaction which one needs to consider. Like we have the pile soil interaction, the pile pile interaction, the raft soil interaction, and the pile raft interaction within itself. So in such cases, a simulation of this interaction becomes very much important. With the traditional approach, they count for one or two interaction. But with the numerical analysis, now all the interactions could be considered in the model. So how do we do the preliminary analysis in the numerical method? So in the preliminary analysis, one need to check the feasibility of the pile raft and at least predict with the minimum number of the piles, as I have already discussed. So what we do is that we create a model, we consider only raft and let's say pile raft, and then we check for the maximum displacement and the maximum differential settlement which is occurring in the pile, and thus we can decide whether one should go for raft only or whether one should go for pile raft. So this is the model, basically this is the analysis which we'll be performing today in our case study. We'll be considering two type of foundation, one raft only and other pile raft, and we'll check that what is the maximum displacement and what is the differential settlement which is occurring in our model. So, and we'll decide that whether we should go for pile raft or raft only. Now with the complete analysis with the numerical method, the first is the spacing of the piles. So based on the design criteria, let's say if the design criteria says that the displacement should not be more than a particular value, it is totally a hit and trial approach. So you could consider two types of spacing and then you can run the analysis and get the results. The second is the pile diameter, for which you can use the parametric study option, where you can just change the pile dia and get the analysis result for the same model. The third one is the pile location or arrangement of the piles. It is similar to the spacing of the piles and it is just hit and trial method. So what one can do is that they can consider two foundations, let's say with a particular raft at depth and particular pile arrangement, and similarly you can consider other raft with a different depth and with a more dense pile combination, and thus you can see that whether it satisfies your design criteria. So for today's case study, what we'll be doing is that basically I'll show you how to import the model from GEN into GTS NX, and then I will model the foundation in GTS NX, and then we'll be modeling two types of foundation, pile raft foundation and raft foundation, for the same model, and we'll see that how the displacement or how the differential settlement occurs. So today's presentation will mainly focus on this case study, and I will show you how easy it is to work on with GTS NX. So first of all, this is the product MIDAS GEN interface, and I have created a simple building. So to import this file, just go to File, and in the Export option, go to MXT file, that is for FEA and GTS. FEA and GTS both are product of MIDAS. So let the name be GEN file and just save it. So now you can just close it. Now you can open GTS NX. So File, New. So this is basically the interface of GTS NX. So as soon as you open a new file, the model will ask for the type of modeling which you want to go for, whether it is 3D, 2D, and the unit system you want to work with. So you can change it initially, and also at later time you can change it. I will show you how. So just click OK. So let's suppose if you want to change the unit system, you can directly use the options which is at the right bottom corner of your screen. Now I will just import the building model. So go to the GTS NX icon, import, and go to MIDAS MXT. Just select the file which you have created and click Open. So as soon as you do this, the building model is automatically imported, and now to see the properties which you have defined, you need to go to property 1D and you can see the columns and beams. Since we are going to define, we are going to create the foundation itself, I will just delete the boundary condition. So go to analysis. You can see that we have three tabs: model, analysis, and results. In the analysis, all the boundary and all the load function could be defined. So go to boundary and just delete the boundary set. Okay. So now I will just create the foundation for this particular model. So I'll just move the work plane. So move work plane, click on normal, and you can just reset to GCS. So click OK. Now to create the foundation, what I would be doing is that I would just create the rectangle and I would extrude the geometry to form the solid. I will just, it will be more clear when I will demonstrate it to you. So this is basically the interface of GTS NX. So you can see that all the geometric function could be found in this tab bar. Then we have the meshing, then static slope analysis, and similarly for different analysis it has been tabbed into different forms so that one need not spend too much time learning GTS NX. So just click on rectangle. So just input the point as 0, 0, press enter, and as soon as you press enter, the method changes to relative dx or dy. So this means that now the input which you are inputting, it is relative to your first point. So with origin there is no such an issue. So just click apply. So you can see the rectangle is formed. So this is basically my raft. Now next thing which I want to create is basically my soil model. So once again I would create one more rectangle. So just input the coordinate as -4, -4, and the relative distance, let's say 17, 17. So enter. So you can see that there has been created two rectangles. One is basically for my raft and the other is for my soil model. So now I need to make my solid geometry. So just go to extrude. So in the extrude option, so whenever you want to select a particular type of element or particular type of curve, this is the selection filter. So just make it basic, so it automatically take care of wire. Wire is nothing but a closed loop of edges. So that is what a rectangle is. So just select the target object. So this is my raft, let's say. Now select the direction in which you want to extrude. So just select that particular axis. And the length, let's say the depth of the raft which I will be keeping is 0.3. So now you can just preview it. So you can see that it's coming topwards and I want it downwards. So you can just reverse the direction and click apply. So my raft is created. Now next I would create my geometry for the soil model. So once again you just change it to basic, let it be wire, and just click the outer rectangle. Select the direction and let the length now being 2 meters. You can just preview it. Preview helps to minimize the error in case of modeling, and click apply. So this is my top layer of soil. Now I will just select the bottommost face and I will extrude it once again. So just select that axis and let's say the length being 8 meters. So just preview it and click OK. So this is basically my solid modeling. Now in this particular case, the piles which I am considering, I would be defining them as beam element. So I would just generate curves for them. So in the model, in the geometry option, you can find all the geometry which you have created, like the two curves, that is the two rectangles, and all the three solids. So whenever you want to check or uncheck, you can use these options. So let us uncheck two solids and let the raft be there. Now what I am doing is that I am creating a pile just below each column. So I will show you how easy it is to create with GTS NX. Just go to geometry and use the command line and use the there is two type of line, 2D and 3D. 2D is basically when you want to create a line in the working plane, and 3D is when you want to move out of the working plane. So we'll be going for 3D and just input the coordinates where you want to create your pile and just press enter. And now once again relative, so let the depth of the pile being 3 meter, so click OK. So you can see that your pile has been created. Now to create more number of piles, what you can do is that you can use the option translate. So you can go to geometry and in the option transform you can use the option translate. So just click on translate. So once you have created a curve, what you can do is that you can just translate it at the particular location you want. So just select that particular curve and select the direction in which you want to extrude. So let it be the x-axis. And what you want to do is you just want to make a copy. So just click on copy. And then the distance, so let the distance be 4 meter, that is the distance between the columns, and the number of times, let's say 2. So once again you can just preview it, so you can see the two curves which will be created. So just click apply. Now to just you can just use the translate for creation of pile in the y direction. So just select the curves and once again select the direction, that is the y-axis in this particular case, and distance 4 meter and times 2. So once again preview it, so you can see the pile being created. So just click OK. So as you can see that the piles, the modeling is so easy with GTS NX. What we have done is we have created the soil model and we have created the curves which will be defined as piles. So next thing which we need to define is basically the properties. So first we'll start with the properties, ground material property. So just click on the mesh option and there you can find the material tab. Now first of all we'll create isotropic material property and the model type, let it be the Moore column, and the name being the top soil for the top layer soils, and the property, the E value being the same, and similarly you need to input the Poisson ratio, the unit weight. Similarly in the nonlinear parameters, cohesion, let the value being, let's say 28, and the frictional angle being 32, and click OK. So the topsoil material property has been created. Next we need to create is for the bottom layer. So once again go to material isotropic and the material type as Moore column, and let the name being bottom soil, and we can just increase the modulus of elasticity. In the nonlinear parameters, let us just change it to 20 and let's say 40. Click OK. So this is my bottom soil property. The next 3D modeling or the next property which we want to consider is that for raft. So let the name being raft. So the property is, let's say, elastic. So you can just give it the E value and the Poisson ratio, let it be 0.2 and the unit weight being 24. So just click OK. So till now what I've did is that I have created the material property for my topsoil, my bottom soil and raft. So the property which we have defined for raft, we can also name it as, let's say, concrete, so that we will be using the same material properties for our piles too. So let the name be concrete and click OK. So close it. So having defined the material property, the next thing we need to define is the type of element to which we are going to assign it. Let's suppose we have the solid elements and we have the 1D or the pile elements. So just go to property. So in the property, so create. So which kind of elements which you are going to use. So we have 3D element. So in the 3D element, so let the name being topsoil and the material type, then you can select it from here, topsoil, and click OK. So the topsoil material property, which is a 3D property with the topsoil ground material property, has been created. Similarly, create for other properties. Let's say create 3D, and let's say the name being bottom soil. Just select the material as bottom soil and click OK. And finally we have the 3D property that is for raft. So just name as raft, the material, let's say concrete, and click OK. You can see that there is a material property called M40. M40 is basically the beam and column property which we have imported from Gen, and it is automatically considered in the program. You can see that there are two types of property. One is column and other is the beam. These are basically directly imported from MIDAS Gen. Now we'll be creating the property for pile. So create 1D because we are going for a beam element. So you can just select beam, let the name being pile. So material type, whatever you want to consider, M40 or the concrete material property which you have considered. And finally the section. So just click on section and let it be solid round and let the dia be 0.3. Click OK. And click OK once again. So now the pile has been generated. So first of all, we'll assign the ground material properties and then we will generate the pile. So just activate the solids and I'll just deactivate the mesh set. Default mesh set is basically the mesh set for the building which we have imported. So this is the model with me right now. So go to mesh, go to 3D mesh. Just select the object. So this is my first solid and let the size be 0.5. GTS NX provides with two type of measure. One is the default tetra measure and other is the hybrid measure. So you can just select the hybrid measure. Now first of all, I am giving it the property of the topsoil. What I would be doing is that I will be simulating the construction stage analysis because many of the attendees requested for the same. So I'll be showing you how to define the construction stage analysis, and the analysis itself I will change the property to concrete. So for now it is topsoil. So let the name be raft excavation. So just click apply. So the mesh has been created. Now similarly select the other two solids and the topsoil and let it the name being the topsoil main and click apply. So you can go for both kind of meshing. You can go for tetra meshing as well as the hybrid meshing with GTS NX. With its powerful solver and 64-bit platform, it can handle large-scale geometric models as well as analysis. Similarly, just select the bottom layer. The property you need to change bottom soil and let the name being bottom soil and just click OK. In between, if you have any queries, you can write it in the question tab box. I will just reply after the end of the session. So having created the hybrid mesh, then next thing which we need to do is that we need to generate the mesh set for our pile. Similarly, you have to assign the interface property for the pile, and let's suppose if you are considering an end bearing pile, you need to define the tip nodal resistance of the pile, or otherwise you just need to define the skin friction of the pile. So you can go for very fine mesh and you can go for very coarse mesh with such kind of modeling. Now the thing which I want to show you right here is that there is a function called auto connect function in MIDAS GTS. So whenever you are considering a very complex model, what you can do is that you can use the function auto connect function, and what the program will do is that it will automatically generate the coface. Coface is nothing but it is the proper ensurement that the nodal connectivity is automatically taken care of by the program. So I have just meshed it without auto connect to show you that what is the difference. So when you check If you want to check your mesh quality, go to mesh, go to check mesh quality, and in the feature edge, free faces oranges, click apply and go to front view. So you can see that there is no clumsiness in between the mesh edge, so the mesh is fine for this particular case. Now you can just uncheck the solids and uncheck the mesh edge which you have created. So now to generate the 1D mesh, you just click on 1D mesh, select all, because that's why I've unselected all the things. Let the number of divisions being 1, property of pile, and let the name being pile. So click OK. So the mesh has been created. You can see it's very light in color. So next thing which we need to define is the interface behavior, or what we can say the main thing which will take consider of the soil structure interaction. So in the mesh you can see that there is an option called pile tip. Now pile tip, so you need to define the properties. You can select all the elements. So these are basically the piles. You need to create a property. I have not created it earlier just to show you the pile function property. So just go to create, interface, and pile. In the material option, in the model type, you can find pile. Pile is basically a model type created in GTS NX where you can directly input the ultimate shear force and the KT and Kn value, which are basically the shear stiffness and the normal stiffness value. So let the ultimate shear force being 2000 and the shear stiffness value, and finally the normal stiffness value. Just click OK. Just close this window. Let the name being interface and click OK. So we have already selected the element, so you can just click apply. Now the second thing which you need to consider, that is the pile tip. Pile tip is basically considering the end bearing capacity of the pile. So you can just select the end nodes of the pile and you can just define the property as the tip bearing capacity of the pile, and you need to define the tip bearing stiffness for the pile. Click OK and click OK. Now having created the piles and defining the interface properties, if you want to see the section of your property, because till now it was just a beam element, so you can check it, the dia of the pile which has been assigned. So you can see the actual stiffness which is going to take while being considered in the analysis. So now we have defined the geometry, we have defined the material property, we have assigned the property, that is 3D or 1D property, we have created the piles. The next thing which we need to do is the boundary conditions. So let us start first with the piles. So just uncheck the section. So for boundary condition, static slope analysis, in the boundary you can see the constraint. In the constraint we have three types of options: basic, like whenever you want to go for fixed, pin or no rotation, you can directly select. Advanced, where you can control the degree of freedom. So just select all and we'll just restrain it in the RZ direction and let the name being pile constraint. Naming of the boundary set always is helpful whenever you are considering construction stage analysis. So just click apply. Now the next thing is we need to define the boundary condition for our soil mass. So I will just like to show you the advanced option called auto. Auto is an option where it will automatically give the appropriate boundary condition to your model. So let the boundary set name being GS, that stands for ground support, and consider all mesh sets and click OK, and automatically the boundary conditions will be defined for you. Okay, the next thing which we need to consider is the change property option. So I will just uncheck all the mesh sets, so you can just control your vision from here. Similarly in the analysis, if you want to uncheck boundary condition, you can do that. You can uncheck the static load too. So in the model, I have just activated the raft now, which is having the topsoil property. So go to change property. And what I want to do is I want to change the property during the construction stage. So select all the elements. Now these elements are having the topsoil property. So what I will do is that I will excavate it and then I will give it the property of raft. So just select the raft and click OK. So a boundary conditions will be created. You can see that in the analysis in the boundary, a boundary condition has been created for the same. So whenever you activate it, with this method, the property will change to raft or concrete property. Now let us see how we define the construction stage sequence. Initially I told you that I would be considering two types of foundation in a single model, that is one raft and for the pile raft, and I will see that how the displacement are varying and how the differential settlement is reduced with the help of pile raft foundation. So just go to simulate stage. First of all we'll define it. So stage set in the construction stage. So in the stage type, you can perform even the consolidation analysis. Many of the attendees have the query that whether one could perform the consolidation analysis in the construction stage sequence. Yes, you can perform the same considering the construction stage sequence. For now, it will be the stress. Click add, click add. Basically, I am considering two construction stage in a single model. So first stage, define construction stage. So first of all, I would activate my soils. That is, the first stage is basically the original ground condition. So bottom soil, top soil main, raft excavation. I will recall you that it is still having the ground material property, the ground support and the self-weight. I will just clear the displacement to just initialize the stress. Save it. Now the next step, what I will be doing is that I will excavate the soil. That is raft excavation. That is, I will deactivate the mass. So I have excavated the soil. So just save it. Now the next step what I will do is that I will change the excavation, or I will pour in the concrete and form my raft. So what you can do is that you can now activate this mesh shed, but you activate the boundary condition of change property for the same mesh shed. So now it is having the mesh shed with concrete property. So it is as simple as that. So just save it. And finally, we will activate the default mesh shed, or what is our building, which we have imported from MIDAS Gen. So just save it. Close. So we have defined the first stage, in which basically we are only considering the raft foundation. Now let us define the second construction stage. So define construction stage. This is set 2. So once again the same, for you can just activate the first original ground condition and self-weight. And just save it. New, and this will be deactivating our raft. So just save it. New. Now in this stage, in addition to the raft, you can see I have activated the raft with the boundary condition. I would be activating all my pile, and I have to activate the pile constraints. So just save it. So now I'm going for pile raft foundation, and finally you can use the default mesh. Save. So this is very simple to define the construction stage analysis with MIDAS GTS NX. Now you just need to generate the analysis case. Go to analysis, general, the solution type, just select construction stage. This is CS, that is construction stage with raft. In the analysis control, you can just check on the initial stage for the stress analysis as 1, and also you can control the other parameters like iteration, the number of iteration from here. We'll be using the default value. Just click apply. And the second will be the CS with pile raft. So in the analysis control, it's same coming. So construction stage will be construction stage set 2. And in the analysis control, once again, you can select the construction stage 5. Click OK and click OK. So in the same model, you can create two types of construction stage and consider the analysis for different kind of foundation. So it becomes very simple. You need not create two types of foundation for the same model. So after that you need to perform the analysis. Just perform and click OK. So after the analysis, I have already have an analyzed file. I will just open it for you. Okay. So this is basically my analyzed file with my building. So let us see the results. So in the results, you can see there are two types of construction stage sequences which we use to define the stages, that is CS with raft and CS with pile raft. So at each stage now you can see the displacement ty, tz direction. Now if you want to consider for a particular method, let's say we are now interested in the raft, you want to see the displacement only in the raft. So what you can do is that you can just uncheck the other layers and you can see basically how the displacement is taking place in the raft. Now to see the values, there are various options, because with finite element modeling always the problem is how to extract the results. Now to see the values, you can use the option probe. With probe, what you can do, you can just click maximum, minimum. It will directly show you where the maximum value is coming and where the minimum value is coming. Also, if you want to check at particular node, you just click on that particular node and it will show you the value. So this is how you can extract the results, especially for the displacement. Similarly, you can see that you get the various type of beam element forces. So beam element forces are basically, in the first case, as you know, that we have not activated the piles. So here basically the beams stands for the columns and beams which we have imported from MIDAS Gen. So you can also check the bending moment in the same, in the Y direction and in the Z direction. Also the axial force, shear force and shear force in the Z direction. So you can consider even the structural behavior in GTS NX. Now the thing which we are interested is now which kind of foundation which one should consider. So having seen in the excavation for the raft, now let us see that how the displacement varies when we are considering it for the piles. So just activate the piles, and in the result, after the fourth stage, I will check the displacement. So you can see that the displacement, once again you can see, for seeing the value you can just probe the value and you can select. Also, even if you want to get the values in Excel format, so what you can do is that you can go to advanced option, extract. You can just select the analysis case and let's say displacement in TZ direction. Select the cases which you want to. So I'm just unchecking the first stage. Select the nodes, whichever are of your interest, or you can select all also. So for example, I'm just selecting few nodes and click on table. So you can see that how for each stage the displacement changes for various nodes, and you can just export or to it Excel for your report generation. So this is how we get different types of values. Also, if you want to see the beam element forces in piles and shear force in piles, you can consider the same. Similarly, the bending moment in the piles and bending moment in the Z direction for the piles. So this is how we consider the modeling of raft and pile raft, considering the superstructure in the same model. So I'll just, this was the case study which we're doing. Now I'll just move on to the presentation. So I will reply to all the queries once I will just finish my presentation, and then I will take all of your queries. So moving on the presentation. So there are few queries like how to decide the mesh sizes. So as you can see that we have imported the building model, so we should consider the mesh size such as that there is proper nodal connection between the imported beam node and the mesh of your model. So for this I have chosen that criteria, that there should be proper nodal connectivity between the nodes of the imported model and the Raft Foundation which you have created. Now let us do the result interpretation for the case study which we have done. So I have selected few nodes, and you can see that the percentage reduction in the displacement varies between 35 to 40%. Now the most important thing for us was the differential settlement. So you can see that the maximum displacement with raft was coming as like 3.96 mm. With pile raft it was coming as 2.40. So the percentage reduction was almost 39.14. Now differential settlement is basically the maximum and the minimum settlement consideration. So you can see that it was something around 2.49 with raft, and it got reduced to 1.33 with pile raft. So with it almost like 46% reduction in that displacement. So we conclude that the pile raft foundation helps in reducing the maximum settlement and has considerable effect in reducing the differential settlement. So moving on. So what are the advantages of considering the superstructure in GTS NX? The first advantage is that now you have a real ground simulation considering the subsurface soil profile variation. So if you have some small soft ground layer or like a small patch of soil, that could also be considered, giving you a real simulation of what you want to consider. Similarly, now you can consider the soil structure interaction to evaluate the pile raft analysis rather than going for spring stiffness. And finally, now you can perform the dynamic analysis of whole structure considering the damping of soil. So you can see in the figure the response spectrum analysis for such kind of model, and this are basically showing the displacement contours in a particular direction. Now next we'll dealing with soil modeling for structural design. So as you can see that whenever we go for a structural approach, we go for the wrinkler springs model, where the wrinkler springs themselves represents the soil, and the foundation helps us to locate the settlements, how the settlement is going to take place. Whereas in geotechnical approach, we go for the continuum model. We have two types of spaces, like elastic spaces, which are defined with E and nu value, and the inelastic spaces where we consider the E, nu, C and phi value. So determination of spring stiffness has always been a problem for structural engineer. So spring stiffness is nothing but the ratio of pressure or load over displacement. Now the spring stiffness very much depends on the foundation response. As we know, we have two types of foundation. One is the rigid foundation and the other is the flexible foundation. So first of all, let us study how there is change in the foundation response. So as you can see that whenever we go for rigid foundation in the structural approach, the stress distribution always comes as uniform from the below, and the settlement is also considered as uniform. So when compared to the real ground situation which we obtain in the continuum model, the stress distribution is very much different what we actually have in our structural model. That is, we have a very ununiform pressure distribution with very high stiffness at the ends. And also in the settlement you can see that there is a curving end at the ends. So that is also not considered when one go for the structural approach, and this is how the foundation response differs whenever you are considering the rigid foundation. Now next is the foundation response for flexible foundation. In this, the stress distribution variation is very much expected or very much similar to what we expect in the structural behavior. But once again, if you see that the settlement variation is not very much uniform, but it is very much different from what we obtain in the continuum model and structural model. Now the solution adopted to consider the stress variation was a very approximate approach. The stiffness of the outermost springs was increased to account for the increase in soil rigidity. For stiff soil, like the outer spring stiffness was increased by, let's say, 30 to 40%, and for soft soil they may be increased by 2 to 3 times. So this is the general practice which one adopt for considering the change in variation of the stiffness. Now what one could do is that you can use GTS NX and MIDAS Gen for the calculation of spring stiffness. First is you need to generate the building with raft as plate element and with fixed boundary condition. Then run the analysis, and what you can obtain is that you can obtain the reaction at each node of the plate element. Now generate the same raft, with the same meshing, and now you can model the soil mass in GTS NX, and you can apply the reaction which you obtained at each node obtained in the previous step. And then finally you can run the analysis with particular loads in GTS NX, and thus you can obtain the reaction as P upon the displacement, that is the reaction upon the displacement. So then this iteration goes on between the structural engineer and geotechnical engineer. Structural engineer provides initially with the column loads, geotechnical engineer provides with the stiffness, and this iteration goes on until a prescribed convergence criteria. Let's suppose if the convergence criteria is settlement, you can see that we have two different results for two different models and they are approximately the same. So thus you can converge your model and you can say that this is the particular place where you stop and you obtain the final spring stiffness for your model. So finally I would just like to give a brief introduction of the PY nonlinear analysis. PY nonlinear analysis is basically different PY curves have been developed by different institutes to consider the nonlinear behavior of the soils. So in Soilworks one can perform the PY nonlinear analysis. Now to talk about the PY nonlinear analysis, in this basically the pile is a divided beam and the soil is defined as the nonlinear spring. Now having obtained the nonlinear spring PY curve for each layer, what one will do is that we obtain the deflection at each pile segment after the analysis, and that is after the applying load, and then depending on the deflection one calculate the soil resistance from the PY curve. Now deflections and soil pressures are interconnected, and the iterations are obtained, and iterations are mainly performed to obtain the correct value of displacement for that particular layer. So this is basically based on the finite difference method. So thus whenever you want to consider such kind of analysis, basically you can consider Soilworks, which is basically a 2D software, but you can consider the 3D arrangement of the soil and you can obtain the horizontal displacement, the movement, shear force, ground reaction, as well as the response PY curve for that particular node at particular location of the pile. So this is basically what one can do with Soilworks. So this is just to give a brief introduction of the capability of MIDAS Soilworks. So with this, I would just like to summarize what we have learned today. So first of all, we learned about the design approach of the pile raft using the numerical analysis, that is the preliminary as well as the complete analysis, the consider of superstructure model from MIDAS Gen to MIDAS GTS NX, how to determine the spring stiffness for the structural model, the 3D modeling of the pile raft foundation in GTS NX, and the effectiveness of the pile raft in reducing the differential settlement, which could also be a criteria for the preliminary analysis to select which type of foundation one should go with. So with this, I would like to end this webinar. Thank you very much to all of you for attending this webinar. If you have any further queries, kindly contact us at techsupport@midasit.com. Regarding our next webinar topic will be soil structure interaction for soil excavation using 3D finite element method, that it will be on June 10th, 3 p.m. and our final presentation of this geotechnical webinar series will be on June 24th, 3 p.m. So thank you very much all, and if you have any queries, kindly write us at techsupport@midasit.com.